introduction of what? Sodium hydroxide. We can also remove it by addition of sodium carbonate. You can also remove it by addition of what? Sodium carbonate. Then one that is the most accurate and is not often used is ion exchange resin. Ion exchange resin that can also be used to remove hardness in water. Ion exchange resin, which we ought to have learned. This is just to refresh your memory on what you have learned in your previous lesson. So we have addition of sodium hydroxide, then addition of sodium carbonate. Then let's talk about the purification of water. The steps. Purification of water. How can water be purified for the usage in the urban area? Dirty water can be purified first before it can be fit for drinking or for some other domestic purposes. So in that situation, the first thing to do is the introduction of alum, which can be KAlSO4 and the essence of this one is to coagulate the particles of dirt. It will clump them together. So when it clump them together, they now form a kind of heavy compound that will now be what? Soluble. That will now be insoluble, that will go in. So which can be what? Filtered off. Then after the filtration, the next thing is the introduction of chlorine. The introduction of chlorine, you will introduce chlorine so as to do what? To kill the germs. To kill germs. That's the essence, that's the significance of introducing chlorine. After the deaths have been filtered off, then we introduce chlorine to kill the germs in the system. Then after the germ, then the introduction of fluorine. We are using the noble gases. I said the halogens. Then we have introduction of fluorine. And what is the significance of fluorine? Fluorine prevents tooth decay. To prevent tooth decay. So it's the fluorine that prevents tooth decay. Then the next thing is to introduce iodine. Introduction of iodine. Introduction of iodine. So what's the significance of iodine? Is to prevent goiter. To prevent goiter. What is goiter? Goiter is the abnormal enlargement of the what? Thyroid gland. So we introduce iodine to prevent goiter. Then the next thing, we have salts. Though I'm not going to treat this extensively here. Salt. What is salt? Salt is a compound formed, or the compound derived when part or all the ionizable hydrogen from an acid is or are completely replaced by metal or ammonium ion. So what am I saying? If you have, let's say this is what? Hydrochloric acid, which is an acid. When you now have a kind of metal coming in play, so what metal does is to displace this hydrogen. Then you have a scenario like this: sodium chloride plus H plus. So in this situation, all the hydrogen ion has been what? Displaced to form this salt. And this is an example of what? This is an example of a normal salt. The one that we use here, that's an example of what? A complex salt, because you have, apart from the fact that you have your, I said complex salts, double salt, because you have two metal. This one is a metal, this is another metal. So this one is a normal salt, because we have a double salt, such as your argon, a double salt, we have a double salt, we have a normal salt, then we have acidic salt, we have basic salt. Although this is not the aspect to discuss more, I just want to paraphrase this aspect, because salt is another topic or subtopic on its own. So we have double salt, normal salt, acidic salt, basic salt, complex salt, and the likes. So, but under this phenomenon, we have salts behave in a kind of in a way that is not what definite. They behave somehow. Some salts absorb moisture when they are exposed to the atmosphere, while some loses water of crystallization when they are exposed to the atmosphere. Some salts absorb moisture when they are exposed to the atmosphere, while others loses water of crystallization. So let's talk about the concept of what? Efflorescence, deliquescence, and hygroscopy. So efflorescence is a phenomenon whereby salt loses water of crystallization, when they are being exposed to the atmosphere. And the major salts, the salts that have that characteristic is washing soda and global salt. Washing soda. Example, washing soda, which is just the formula of Na2CO3.10H2O. Then we also have global salt, which is also Na2SO4.10H2O. So these salts, when they are exposed to the atmosphere, because of the fact that they are highly efflorescent, they tend to lose 9 out of the 10 molecules of water when they are being exposed to the atmosphere. Take note of that. Also in the case of global salts. So that is the process known as what? Efflorescence. They lose 9 out of their 10 molecules of water of crystallization when they are exposed to the atmosphere. So any salt that has this phenomenon is said to be undergoing efflorescence. Then also deliquescence. Deliquescence is a phenomenon whereby some salts tend to absorb moisture when they are being exposed to the atmosphere, and they eventually turn into solution. Take note of that. Example of such is we have sodium hydroxide, we have iron 3 chloride, we have phosphorus 5 oxide, we have etc. and many more. So these ones, what they do simply is that once you expose them to the atmosphere, they will absorb moisture from the atmosphere and eventually they turn into solution. Take note of that. Then the last here is hygroscopy. Hygroscopy is a phenomenon whereby salts absorb moisture when they are being exposed to the atmosphere, and they will not turn into solution. They remain that way. They do not turn into solution. That is why an example of salts that have that phenomenon is your calcium oxide, copper oxide, Then we have NaNO3, that's sodium triazonitrate 5 salts. So in this situation, this one they undergo what? Hygroscopy. So these ones, they absorb moisture from the atmosphere, but they do not turn to what? Into solution. So in that situation, this one is better used as what? Both of them are better used, but this one is better used as what? Drying agent. What are drying agents? Drying agents are those substances that have strong affinity for moisture or water. So that is why hygroscopy or hygroscopic substance is a better drying agent. Then examples of the substances exhibiting these properties, which I have itemized here. I talked about the use of water and the color change involved when having the test for water. Having identified the various compounds that exhibit this phenomenon, that is fluorescence, deliquescence, and hygroscopy. Distinguish between these phenomena. I've been able to distinguish between the phenomena by saying that fluorescence is the kind of concept whereby when they are exposed, they lose water of crystallization. But in the case of deliquescence and hygroscopy, both of them are used as a drying agent. But the most suitable or the more suitable out of the two is the hygroscopy because of the fact that it absorbs moisture and it does not turn into solution eventually. Then I want to quickly talk about the use of water. It's very common. Water is used in our homes for laundry, cooking, bathing, drinking, and for cleaning household furniture. 2.